So, for the past few years, the story around AI has been, well, just explosive, right? It felt like this unstoppable growth. But what happens when that digital rocket ship of an idea smacks right into the physical world? That's what we're going to dig into today. We're going to look at the very real physical limits that are starting to pull AI's incredible trajectory back down to Earth.
It all really starts with this fundamental conflict. On one hand, you've got what we can call theoretical velocity, this belief that AI progress can just keep accelerating, totally frictionless. But on the other hand, you have structural inertia. And that's just the unavoidable drag from the real world. Things like power grids, supply chains, all the legal stuff. It's this tension right here that's completely reshaping the entire AI industry as we speak.
Okay, so to really get why this friction is such a massive deal, we first have to appreciate the incredible vision that's been driving AI development up to this point.
You see, the common way to think about it is that AI is basically in its adolescence. It's in that teenage phase of super fast, kind of awkward growth, where its abilities are just exploding across every field you can imagine. We're talking way beyond simple tasks now. It's starting to fundamentally reshape really complex industries. Think law, finance, even scientific research.
And the economic promise of this vision? It is absolutely staggering. I mean, the people pushing this believe that if AI keeps getting integrated at this pace, we could see sustained productivity growth of 10, maybe even 20%. To put that into perspective, that's a level of economic change we haven't seen since the Industrial Revolution. It's huge.
And this progress isn't just about what AI can do out in the world. Internally, the models themselves are getting smarter in some really fascinating ways. They're not just crunching data anymore. They're starting to develop the ability to reason, to actually debate options internally, and even to self-critique their own conclusions. They're just becoming way more flexible and, well, creative. So, in theory, that kind of progress should be totally unstoppable, right? But in the real world, well, this incredible digital dream is slamming headfirst into a massive reality check. The physical world is pushing back hard, and it's happening in three really important areas.
All right, constraint number one, and this is maybe the most urgent one. It has nothing to do with code or fancy algorithms. It all comes down to one simple thing: power. We're talking raw physical kilowatts. And here's the problem. AI data centers are just incredibly thirsty for power. And they don't just need it sometimes, they need it 24/7. It's what's called baseload power. The issue is, a lot of our new green energy projects, like solar and wind, are intermittent. They don't generate power all the time, right? The sun isn't always shining. So you've got this fundamental mismatch between the constant power AI needs and the fluctuating power grid we're actually building. And the problem just gets worse from there. Let's say we even had unlimited power. We'd still face a massive bottleneck in just building the specialized hardware that AI actually needs to run. Yeah, and we're not just talking about the famous GPUs that everyone knows about anymore. The real choke points are now in things like high bandwidth memory and the advanced packaging you need to put these super complex chips together. You see, unlike software that you can update in a week, this is heavy industry. We're talking multi-year timelines that involve everything from the initial design and fabrication all the way to navigating tricky geopolitical tensions and export controls. And that brings us to the third constraint. This one is a little quieter, but it's just as powerful a brake on AI adoption. And it's all about one simple question: who takes the blame when something goes wrong? This is a multi-trillion-dollar question, and it's stalling AI's use in really high-stakes fields. I mean, think about it. If an AI gives you bad legal advice or makes a medical misdiagnosis, who's liable? Is it the developer who wrote the code, the person using it, the company that owns it? Without a clear answer to that, progress just grinds to a halt. See, the heart of the problem is this: the entire insurance industry runs on historical data. To insure against anything, companies need to know how often it fails and how much that failure is going to cost. But with these brand new advanced AI systems, there is no history. There's zero actuarial data. And without that data, insurers just can't price the risk. And if you can't insure it, well, a lot of powerful and capable AI systems just end up sitting on the shelf, unused. So, okay, as all these physical and legal constraints really start to bite, the entire strategy for how you win in AI is being forced to change. It's causing this huge pivot in the way the whole industry thinks. And this quote just captures the new reality perfectly.
The old way of thinking was basically scale is all you need, just build bigger and bigger models, throw more data at it. But the new mindset, it's efficiency is all you can afford. In other words, you have to be smart and lean because that's frankly all the real world is going to let you do. And you can see this pivot so clearly. The old strategy was all about these massive, do-everything generalist models running in super power-hungry data centers. The new strategy is completely different. It's about creating smaller, specialized models that are hyper-efficient at doing just one thing really well. And it's also about moving the computing power from the cloud directly onto your local device, your phone, your laptop, to save power, get rid of lag, and, of course, protect your privacy. So what does all this mean for the future then? Where does AI even go from here, now that it has to deal with, the laws of physics? Now, let me be really clear. AI development isn't stopping. This is not the end of progress, not by a long shot. What it is, though, is the end of that simple, frictionless story we were telling ourselves, that AI could just grow infinitely without any consequences. The narrative now is just, well, it's more realistic and, frankly, a whole lot more complex. And what that means is that the leaders of the next wave of AI, they're not just going to be brilliant coders. They're going to have to be masters of the physical world. They'll be experts in energy grids, global supply chains, and figuring out these new insurance and legal frameworks. Success isn't just about having the best algorithm anymore. Because at the end of the day, intelligence has to live somewhere, right? It needs a physical home, it needs chips, it needs power, and it needs a legal system to operate inside of. That physical reality, it's like gravity. It's this powerful, constant, and totally unavoidable force that's now pulling the soaring ambitions of AI back down to Earth. And that leaves us with the final and most critical question. This gravity of the real world, it isn't something to be fought or ignored. The real challenge, and honestly, the huge opportunity, is figuring out how to work with it. The companies and the innovators who crack that puzzle, they're the ones who are going to define the next era of artificial intelligence.